Welcome to my presentation, Industrial Security, a Critical Success Factor. My name is Niels Bucher. I'm Product Manager and Technology Manager at Pilz, and part of my responsibility is the topic Industrial Security. And around about the next 20 minutes, I want to talk with you about the requirements or the necessity of industrial security in our industrial automation applications and provide you with some insights and measures to improve the security of your automation systems. Well, you all know Murphy's Law. And in my career, taking care of industrial security, I was several times thought of Murphy's Law. So under the bottom line, no matter how remote the probability of occurrence exists for a hazard, it's possible it will happen. Just imagine that suddenly the electricity is gone, or there's no water out of the tap, or we do not have access to the internet anymore. These are situations that already happens several times over the whole wide world. And the reasons are different. These can be product issues, these can be misuse, misconfigurations of devices. This can be also attacks to these different infrastructures. Providing electricity or providing pharmaceutical components, food, water treatments, these are all critical infrastructures. And in the whole wide world, in many different countries, these critical infrastructures are forced by law to take measures regarding their industrial security. For example, in Germany, we have by now 1,500 registered systems. But we also need to consider that these systems are provided by integrators that are making the systems, building the machines made out of components, for example, we at Pilz are producing. In addition, with the industrial Internet of Things, the connectivity, the connections from IoT devices via the Internet exchanging information will increase. So there are assumptions that by 2022, we will have 50 billion IoT devices connected to the internet and communicating with each other. On the other hand, in the last 12 months, over the last year, 114 million different types of malware were detected. So malware that wants to attack these many different devices we are, for example, connecting to the Internet of Things. In addition, alone in Germany, over the last 12 months, every day, around about 110,000 systems were infected by so-called bot software. So an attacker takes over remotely these systems and is able to distribute one of these 114 million different malwares that were detected over the last year. Early last year, in March last year, one international company from Europe were attacked by ransomware. Alone in the first 5 days of remediation after these attacks, the company invested 40 million euro in order to bring back their production to operation. This is a very high volume, but in general speaking, also if it's just a few millions for small or middle-sized company, this can be a huge effort and could result in to be bankrupt. Since many years at Pilz, we are taking care of functional safety. So we are protecting the human from the hazards on the machine. But also since many years, we are taking care of industrial security. Every day, human people are interacting with the machines. So it's also very important to protect the machines from the human. For example, against unauthenticated access or misconfiguration. So providing functional safety and to increase the availability of the machine, it is also important to have a closer look to the industrial security in order to provide the high availability. And of course, later on, it's cash money in the pocket if the machine is working according to their design. So let's have a look at some security measures that we are using every single day. So, for example, packet filtering. If you are a support guy and you need to visit a customer in order to work on a machine, first of all, in order to get access to this customer area, we need to walk through the entrance. Typically there's a nice lady sitting asking for our name, with whom we want to talk. So we need to provide information, and in the end we get filtered, and with a final decision if we will get access to the facility. And if the security is high, we are always guided by a local employee, that we only go in that areas where we are allowed to. Second example from our daily work is the user management. Before we can read our emails at work, after powering up our computer, first of all, we need to type in our username and our password. In case we need to get access to certain different file drives, or maybe we need to install a new software, we need to have the correct rights on our computer in order to perform different tasks. So with our user management, the IT is providing to us, they decide what rights we are getting on our computer, for example, in order to install additional software, or we might need to open a ticket to access a certain network drive in order to get important information. Last but not least, in these examples, I'm pretty sure you saw these protected areas with the card reader to get access. So we are protecting the access to different areas within a facility. For example, based on our rights, we are only allowed to access certain office areas, R&D areas. This can be also production environments, server rooms, etc. So there are many, many more examples of daily security measures that we are using, and maybe we do not think about it anymore. But on the bottom line, we are using a lot of these, and we are very familiar with the principles how this works. And let me now, in the next couple of slides, migrate our knowledge to a real example with an industrial automation system. So here we see an automation system that are built up out of different segments. Maybe each segment was manufactured, designed by different integrators, but on the bottom line, it needs to work together. We also see that from point of view of the functional safety, a lot of things were done. We have light curtains, etc., safety PLCs. So in order to operate the machine, it's mandatory to take care of the functional safety to protect the humans. Now we have this existing installation, and the next step is that we need to take care of the industrial security, of the security measures for this setup. So we're talking about the so-called brownfield installation, where we need to do some tasks now. So following the recommended process, first of all, we saw that we have different segments, which I call zones. Here, to simplify the setup, the next steps, I reduce the machine into 3 zones. So we have 2 zones with a gray background, and the overall zone where we have the connection to the upper IT, the cloud connection to different servers, to store the data, to analyze the data for production optimization, etc. But also we might have service PCs that wants to communicate to these zones. So in order to apply security measures, first of all, we need to take care about the different assets that are in this installation and that we need to protect against misuse, against changes, or for example, the denial of service attack. So we see at the bottom in each gray zones some PLCs for the standard process, also for the safety process. We have network equipment, industry graded switches that are connecting these PLCs together, for example, with an HMI or maybe also with a robot. So if we have identified the important assets, next we need to have a look at the communication. Which device is talking with whom? How are they doing it? And that we see here on the next slide. On the one hand, we have the process data. So the PLCs are exchanging information which are typically time critical. So we need to pay closer attention to this typical time sensitive process data in order to take measures later on. On the other hand, we have non-time critical communication, like the big data that we are using for quality control, for analyzing the processes, etc., that goes from the production zones into the cloud, to our cloud servers. Or on the other hand, we have communication from the cloud into the zones, for example, from a service PC, in order to change some configurations or to download a new project to the PLC. Once we know the assets that we need to protect, once we have formed the zones, we can, for example, do some standard packet filtering using a firewall. Here, for example, with our so-called security bridge. So, based on the communications we have identified, we can create rules that we are implementing into the firewalls that are filtering my traffic. So only allow traffic from the zones to the cloud, or the process data between the zones are allowed by the firewalls. On the other hand, we have, by using a firewall, massively reduced the surface attack. So traffic that are not required to be in one of these zones are blocked by the firewall. Most challenging in this environment is a time-critical process communication. Typical firewalls, they are very efficient and very good to filter traffic in case it's not time-critical. Even many industrial-graded firewalls are based on the same principles, and we have implemented these principles for non-time-critical data as well. But the challenge is the process data with its timing requirements. And due to the special design of our security bridge, we are able to implement the security bridge between the zones also for time-critical data in order to guarantee or to provide process communication according to our requirements. Next topic is the user management we saw previously. Also, if we want to do some changes, reconfigure the firewall, download a project to the PLCs, there should be a user management, or it's mandatory to have a user management. First of all, when we establish the connection with the device, here with the firewall, we see via the web-based front end the login screen first. So we need to provide username and passwords. We are handing over these username and passwords, typing into our service PC to the firewall. And in the next step, the firewall is requesting proof of these credentials by an authentication server. So my preferred way is always to use an authentication server, which is typically already available at a customer site. So we have a central management of the users. And first of all, we are checking, is the user, my username and password I have typed in, available in this database? But that's not all. Also, we are having different roles based on our education, on our trainings we have received. So next to my credentials, the authentication server knows which rights I have, which actions I can perform for reconfiguring a firewall, or for example, downloading a project or talking to a PLC. So if I'm lucky, I'm part of this user database and I have the rights to configure the firewall. The authentication server provides this information to the firewall, and the firewall later on will grant me access. In addition, this device also provides a local database, and I always recommend also to use a local database. Especially in a situation where I have, for example, communication outage from my zones to the authentication server. If we cannot query the authentication server, we are not able to log in. So there should be always an additional path, an additional option for redundancy purposes to get access to the components I need to communicate with. The third example I previously mentioned was a protected access. So for example, I have a machine, my integrator needs to work on that machine, and he needs protected access to my zone, to the environment within the zone, to the components. So here, as the integrator is physically not part of the zone, we need to find a way that the service PC virtually gets part of this network. Or in other words, we need a virtual private network, VPN. So first of all, we are transmitting data to a potentially unsecure network. So first of all, the service PC with a VPN functionality needs to establish an encrypted communication with my firewall. By having this encryption, we have protected the data against potential changes by an attacker, and also we can prove the integrity of the data. No one else can read the data, so also stealing intellectual property in this scenario would not be possible. Once the encryption is established, we know a familiar situation. We need to authenticate ourselves. We need to get access to that zone or to specific components of that zones, and we need to provide, again, for example, a username and a password. And then, like previously shown in the example, for the user management, the credentials are checked by the firewall against an authentication server. The server tells the firewall that I'm available in the database and with which rights I can access the network. Maybe I have only access to a few components, as I'm just working on the PLCs. A different service guy might have access to the infrastructure devices, as he has the right training to configure the switches, the firewalls, etc. So once the access is granted, and we see it here with a gray background, we have a secure communication through an unprotected network, and it feels like that the remote technician is part of the local area network of the zone with his service PCs, although connected through the unsecure environment. So these are just some functions that we have implemented into our security bridge. But it's not only about the functions when we talk about industrial security. When we started thinking about this firewall, specifically designed for automation environments and also for time-critical process communication, we have established a secure development process according to the standard IEC 62443. And that we have proven by the German TÜV, and we received the certificate also for our process and for the functionality according to IEC 62443 end of 2017. And by now we have rolled out this secure development process and all the other topics that comes around industrial security for product development as our standard process for all our product developments. Although we are coming to my last slide, we are not at the end when we talk about industrial security. Industrial security is a life cycle. It's a process that we need to repeat on and on and on. Every day new technologies are developed, existing technologies are improved, but also vulnerabilities might be detected in products that needs to be fixed by the manufacturer, and patches needs to be provided to the customer side. And we also saw the huge amount of new malware and variants that are developed and created on a daily basis, and this will continue, and we will still have to think about industrial security to protect our components, our machines, and also to provide the availability of the machines and of the functional safety functionality. So I'm still here for your questions. I'm happy that you followed my presentation, and I'm looking forward to also see you in the future live to talk about the industrial security of your machines and how we can help you to improve the security in your automation systems. Thank you very much.